Hey, what's up, guys? Okay, so in this video, I want to talk about the skins, which is not fine. This is my algebra geometry lecture. I hope you guys subscribe to my channel. Okay, so we are talking about skins are not fine. So since we talk about definition of general skin, right? So it's natural to ask that what is this? What might be a skin which is not affine? Okay. So the reference that one can check out of Bakel chapter 3, and there are 3 examples. So I will make 3 small videos. Okay, so the strategy, let me just talk about strategy. So strategy is to if somebody give you the ring space and then you want to say that this guy is not affine, then basically you are asking that you are just asking that you cannot find A, right? You cannot find a commutative ring A such that this is true. But you will not have a chance to iterate all the possible A, right? So the standard strategy is that you calculate a global section. It should be A, right? And let's call this A. And so if X is affine, then X should be the same as spec A. Okay. And OX should be also as a sheaf morphism, sheaf isomorphism to all spec A. And hopefully by these 2 examples that you will see the contradictions. If you see the contradictions, then you're happily proof that this is not fine. Okay, so this is the first example is very simple, which is also people like to ask, is the affine line with double origin. I don't like these examples, but these examples need to be the standard. It's a simple one. Okay, so what's a finite of double origin? So we need to use the gluing of skin. So remember that if somebody give you the 2 skin x1, x2, then you can take a u, right? Some open set u1 and u2, and then you can just glue in them. You're just saying they are the same, right? But this provide that you need to define a map to glue in them. Okay, so let's take x1 to be a fine line. So it's k of x. Let's call it k of a small x1. And let's call u1 to be x1 minus the origin. So you can imagine that this is spec of sorry, so x1 should be right as spec of k of x1, and the spectrum of k of x1 1 over x1, right? Because now x1 can be 0. Okay, so you can define x2, do the same thing, spec of kx2, and u2 to be the spec of k of x2 1 over x2. So it's the same as x2 minus the origin. Okay, so I can attach. So I can define a map from just u1 identify with u2 by just map x1 to x2. Okay, so this is so simple. This is our u1, and this is our u2. And the x1 is origin, x2 is origin, and then you do the gluing, right? And then you do the gluing of these 2, right? So now this become the same thing. Become the same thing, right? So you get a fine line. You can imagine that this is a fine line, but with double origin. Okay. Okay, so simple. So now we need to calculate global, right? Global function on it. Right. So basically, we're just asking this. Okay. But now this gluing is simple, right? So we know that suppose. Okay, so since we're gluing u1 and u2, right? So the global function on u1 should be the same as global function on u2. Okay, so let's take, if I can take f x1, right, belongs to k of x1, and I take g of x2 to be k of x2, and I want to say that they are agree, right? Agree, right, on u1 and u2, right? Since there are the u1 and u2 are already identified. But this is the same as fx1 is the same as g of x2, right? When x1 is non-zero. And there are connections that I map x1 to x2, right? So I map x1 to x2. So I can just replace this x2 to be x1. Okay, so you are just asking that the fx1 equals to gx1 when x1 is 0, right? But fx1 is a polynomial, right? If this f is the same as another polynomial, but only one point is different, for non-zero points, then this is the same as fx1 is the same as gx1. So you don't need this condition, right? Because polynomial are continuous. Okay. So this will tell you that basically the global section is exactly the same as you take any k of x1, any k of x. Okay. Because your condition is very simple that the two of these affine line has the same function, and they agree. Okay. Okay. So now we know that this is k of x, right? So x should be, if x is affine, then S should homeomorphic to spec of k. Okay, so this is the affine line. Okay, by definition. Okay, but this has a contradiction because what? Because we know that in AK1 that prime ideal, sorry, the maximum ideal is bijective to the points on AK1. So this is basically the same as, this is exactly the same as if you, let's say K is algebraic closed, so any point A, right, will map into the prime ideal of K of X, where just X minus A. Okay, and obviously this is bijective. Okay, but now since we have double origin, right, so both origin, this is simple, both origin maps to the same ideal X, right? Both origin maps to the same ideal of X, or is the same, or conversely, you would say the X, right? This X will correspond to 2 points. Okay, then this is not a fine scheme. Okay, so this example is very simple. So as I say that actually if you just do this, right, since the global section is still the same, it's the same as one affine line, right? But there's another additional points. Then this violate this property of affine line. So basically, this is a standard strategy. In the next video, if we talk about the projective line or maybe the affine plane minus origin, then we are just doing the same thing, right? We will first calculate the global section, and then we assume that, oh, these guys are not, it's affine, and we want to say there is a contradiction. Hope to see you guys in the next videos.